first item on the quiz was draw a frequency distribution of these 9 numbers. So n is equal to 9 here. Then find the mode, the median, the midpoint, the mean, and the range. What we need to do is find out, are there any zeros? No. Are there any ones? Yes, there's 1, 1. So we're going to draw a box whose height is 1 above the 1. So the frequency of 1 is 1. How many 2's are there? Well, there's 1, 2. So we draw a box whose height is 1 over the 2. Are there any 3's? No. So the height of the box is 0, showing that there are 0 3's. Any 4's? No, but there's a 5. So 0 4's, 1 5. You could fill these in if you like. Are there any 6's? Yes, 1 6. Any 7's and 8's? No. So their height is 0 and 0. Is there a 9? Yes, there's 1 9 and 4 10's. So we have 1 9 and 4 10's. So the height of the box over 10 is 4. So I can come over here to see what 4 would be. And 4, I'm going to draw a box whose height is 4. 1 2 3 4. There should be 9 because there are 9 cases, so we can count them. 1 2 3 4 5 6 7 8 9. So that adds up. I haven't left anything out. How many got that? I could have asked, what's the shape of this distribution? Is it symmetric? And the answer would be no, it's not symmetric. Is it asymmetric? Yes, that means it's not symmetric. Is it positively skewed or negatively skewed? Well, it's negatively skewed. Didn't ask that question, but we can also note that it's negatively skewed. Find the mode. The mode is that value of x that's most frequent, and so the value of the mode is 10. So the mode is equal to 10. How many got that? Okay. Any questions about the mode? The mode is that value of x that's most frequent. It's not enough to remember that the mode, the median, the mean, the midpoint, they're all the geometric mean, the harmonic mean. These are all measures of central tendency. True, they're all measures of central tendency, but you need to know which one is which so that you can look back at a statistic, as they say, read the chapter or the well-chosen average. These are all averages, but they create very different impressions. All right, the median is that value of x that an equal number of cases are above and below, and 9 qualifies because there are 4 cases below and 4 above and 1 right at 9, so the median is 9. How many got the median? All right, any questions about the median?
So you're not supposed to put it in order?
You could put them in order and then take the middle one. That's a way to do it, and that would get you, in a sense, they are in order here, right? 1 2 4 5 9 10 10 10 10. Right? So once you draw this distribution, they're in order. You could rearrange these numbers in order, in which case it'd be 1 2 5 6 9 10 10 10 10, right? And in which case it'd be the 9. Now, if you put them in order and there's an even number of numbers, one of the things about the median, it's not always unique. The mode may not be unique. You could have a bimodal distribution, in which case there's 2 modes. You could have a trimodal distribution with 3 modes. Uniform distribution where all the values are modes. And the median may not be unique. Suppose there were only 8 numbers here, in which case, if you put them in order, you'd have no middle one there exactly. And so any number between 6 and 10, like 6.5, 7.5, 8, 8.1, 8.99, 9.1, 2, 5, 6, 7, all these numbers would qualify as the median. So any number between 6 and 10 would be a median. It would be not unique in that case. But in this case right here, since there were an odd number of numbers and one score right there, the median was unique in this distribution. All right. The midpoint is the minimum plus the maximum divided by 2. The minimum is 1 plus the maximum is 10 divided by 2. That's 11 divided by 2. That's 5.5. So that's the midpoint. So here's our median. Median is 9. The midpoint is 5.5. And the mean is the sum of the numbers. So you should have memorized already that x bar is equal to the sum from I equals 1 to n of x sub I divided by n. And the sum from I equals 1 to n of x sub I, that's equal to x1 plus x2 plus, and so on, plus x sub n divided by n. And in this case, that's 10 plus 2 plus 1 plus 10 plus 9 plus 6 plus 10 plus 10 plus 5 is 63 divided by 9 is equal to 7. And I got 7 for the mean. All right, good. Any questions about how to calculate the mean? So you take all the numbers and add them up and divide by the number of numbers you have. Now suppose you take one of these tens and you made it 1,000,000. Would that change the mean? Yes, because the sum of all the numbers, all of a sudden, instead of it being 10 here, be 1,000,000, and you divide by 9. That would increase the mean by a whole lot. Would it change the median? No, wouldn't change the median at all in this case, right? Would it change the midpoint? Yes. Would it change the mode? No. Mode would still be 10 in that case. So some of these numbers depend on all the numbers, and some of them are sort of less sensitive to individual numbers. It's one of the properties of the mean. So the mean in our case was equal to 7. This is a negatively skewed distribution. In a negatively skewed distribution, the mean, notice there are no scores of 7. 7 is never the right answer. The range is equal to the maximum minus the minimum, and so that's 10 minus 1 is equal to 9. So the range was 9, and they got the range. All right. Any questions about how to draw a frequency distribution? Is that a question? Did I make a mistake?
Well, no, I just didn't. Did you say that the median would change if you took one of the tens and turned it into
No, it
1,000,000? Because it
No,
wouldn't, would it?
It would not.
No,
No,
okay.
if
So you said the midpoint would change.
The midpoint
Yeah,
would
all right, I
change.
get
That's right,
that.
because the midpoint is the minimum plus the maximum divided by 2. And if I change the maximum from
To
10 to
1,000,000,
1,000,000, that would really
Okay.
change the midpoint, wouldn't it?
Yeah.
And it would change but it wouldn't change the mode. The most most frequent value would still be the 10, and it wouldn't change the median. So some of these numbers are really sensitive. Mean is sensitive, midpoint is sensitive to changing the extremes. If I change one of the numbers in here and move it around, it doesn't change the midpoint at all. So the midpoint is completely insensitive to moving our numbers around inside. Just depends on the two extremes. But the mean would change if you change these numbers around inside. All right, what are the claims to fame of these measures of central tendency, and why do we have these different measures? Well, each of these numbers has a different claim to fame. They create different impressions. If you were to say, you know, the average criminal commits commits 5 crimes when they get out, or 10 crimes, it sounds quite different. 5.5 is the average number of crimes committed by these criminals when they get out, versus 10 is the average. Each of these qualifies as the word average. The other word that we use, because the word average is used so variously, is measures of central tendency. They're measures of the sort of the center of this group of numbers, because they tend to be in the middle of the numbers, although the mode in this case is at one at the end. So here are their claims to fame. The mode always is the number that's most often right. So if you were trying to choose one number to represent all these numbers, and the number of numbers could be, you know, here we've only got 9 numbers, so you could just as well list them. But sometimes people start talking about the population of the United States. What is the population of the United States like? And you're talking, you know, depends on who you're going to count, but 300 million numbers or so. Right? Start talking about the population of the world, there's an awful lot of numbers. People say, let's choose one number to represent all the numbers. Well, the mode is a claim to fame. Its claim to fame is it's the number that's most often correct. If you were going to guess these numbers, well, let's say we're playing a guessing game, and you want to know what should I guess if I want to be right, the mode is going to minimize the number of errors. In other words, it's most often right if you're either right or wrong. So you're either right, exactly right, or you're wrong. And if all that counts as being right, the mode is your number. The median minimizes the sum of the absolute errors. So let's say you were going to make a guess and then ask how well does that guess fit these numbers. And here's our notion of fit. We're going to say the fit is a function of your guess, G. So G is your guess. We want to make a guess, and here's our measure of fit. It's equal to the sum from I equals 1 to n of the absolute difference between the number and your guess. This is horseshoes. In horseshoes, what do? You try to hit the target as close as you can. And what do? You measure how far away the horseshoe, where it landed compared to that target, what you're aiming at. So if your score in shooting at something is how far off were you, this minimizes the sum of the distances to the other numbers. We take each number, subtract the guess, take the absolute value of it. That's the size of your error. That's the absolute error. That's the distance. The midpoint minimizes the worst error. Midpoint minimizes the worst mistake that you can make. So if we're playing a guessing game where I get to wait till you make a guess, then I get to choose one of the numbers. So let's play a little guessing game here. Here's the numbers. Your job is to predict which ones are going to come out. You're the parole board. You're trying to guess how many crimes these people are going to commit. If you let this one go. All right, this is what they're doing right now. California has got overflowed jails. They've got to let people go. They want to predict how many crimes are they going to commit. If you don't know anything, what can you do? You can just make a guess, right? That's why I call it a guess. Not a very informed prediction, just a guess. Remember, there's things you might want to predict about human behavior. Who's going to flunk out of law school? If you let them into law school and they sit there for a year taking up a seat, some of them are going to flunk out. Medical school. It costs a lot of money to put somebody in medical school. Some of them are going to flunk out. Should you admit those people that are destined to flunk out? No, you should admit the ones that are going to succeed, become doctors. You're going to hire people. You want to hire people that are going to do a good job for your company, not people that are going to screw up and make your company run out of money. Releasing prisoners. You want to let the people go who are going to support their wife and children and not end up having to come back through the court system and be sent back to jail again. Cause other people's grief and suffering when they've been released. So you want to be able to make an educated guess. In this case, we're just guessing based on nothing so far, but we'll later learn how to make more educated guesses. So if you're playing a game like nuclear war, you want to minimize the worst thing that can happen to you, right? Or if you're playing an opponent game, so you're going to make a guess as to one of these numbers. These are the numbers right here. I've got the cards. I don't know what they are. You're going to make a guess But I get to choose which number to give you depending on your guess. So if you guess 10, that's the most often right, right? What am I going to do? I'm going to choose 1. And how much is it going to cost you? Well, your mistake is going to be 9 now. So it's going to cost you $9. So if you're in an opponent situation, sometimes what you want to do is minimize the worst error. So if you're playing nuclear war, you want to minimize the worst thing that can happen to you, or if you're playing war in general, you oftentimes think about minimizing the worst thing that can happen. Now the mean minimizes the average, or the mean, I'll write it as a mean squared error. So we're going to play the mean squared error game, also known as the variance game. What's the mean squared error? Well, let's figure out what's a squared error. We take x sub I, that's the actual number, subtract your guess, and then we square it, and we're going to add them up and divide by the number of numbers, and that's the mean squared error. So this is the error, we square it, add it up, divide by n, that's the mean squared error. Let's play the game for a little while and see if you can figure out how to play it here in a bit. Now it's time to start way over here. I'm looking at a number here. If you can read my mind, you'll be able to guess it. So you got to guess. It's one of those numbers from over there. What do you guess? We're going to take your guess, subtract the actual number, square it, and that'll be your cost in dollars. 2. It's 10. All right? So 10, that's the actual number, minus your guess, that was 2. That's 8, $64 after class. Okay? What do you guess? What?
6.
She guesses 6, it was 2. She was thinking of the next number. I had ESP for the next card, the one I wasn't thinking of. All right, 6 minus 2, that's 4, squared $16. Let's shuffle them up here.
10.
10 it was.
8. I mean 9.
What's that?
9.
9. 9 minus 2 is 7, $49 after class.
10.
10 was 10. 9. 9 minus 1, 8, squared, $64. 4. Difference is 2, squared, $4.
5.
It's 10, $25. Everybody get the idea? Squared mistake. Now, why are you guessing these other strange numbers? What should you be doing if you want to minimize the average squared mistake?
Guess the mean.
What should you be guessing? What's it say on the board? The mean minimizes the mean squared error. The mean is the best thing you could do. Will you ever be right?
No.
No, but that's the best thing you can do with these numbers. Now, if you don't believe me, make these cards, play it with your friends. Now, should you guess a whole bunch of different numbers? Try something different in every trial according to how you feel? No, that's even worse. Try it out. You have your friends do it. Play it, add it up, square the mistakes, add it up, find out how much money changes hands. Now we have a special name for the average squared error. Besides calling it the mean squared error, which sometimes gets abbreviated MSE, mean squared error, it's also called the variance. And whereas the mean, the median, the mode, the midpoint, these are measures of central tendency, the variance is a measure of spread, how spread out the numbers are. The more spread out the numbers are, the bigger the variance. If the numbers aren't equal to each other, you have a big variance. So let's calculate variance. Here's another example over here for calculating the variance. The formula, so here's the formula to memorize. The symbol we use is s squared sub x. S squared sub x and it's called the variance, and it's equal to this. So this is equal to s squared sub x. So let's find it. Well, except, it's this, except for one thing, that you are smart enough to put the mean in as your guess. So if you are smart enough to guess the mean, then it's called the variance. So that's the best you could do, is using the mean. So we're going to take each number. So the formula says what we have to do, I guess I'll write it over here again. S squared sub x is equal to the sum from I equals 1 to n. We take each score, we subtract the mean, because that's the best guess you can do. Square it and divide by n. It's the average square mistake you'll make if you do what you should do, which is guess the mean. And what was it in this case? 7. You should guess 7 in this case. And if you guess 7, you never would be right, but it would cost you less than anything else. So the least cost sometimes means you sometimes are worse off. You might have been lucky. Few people were lucky guessing 10. But you could have guessed 10 and 1 would occur, in which case how much does it cost you? Yeah, 81 bucks. So it costs a lot more. So what we need to do, according to this formula, so this is the sum of x1 minus x bar squared plus x2 minus x bar squared plus, and so on up to xn minus x bar squared, all divided by n. So we need to find each of these numbers, subtract the mean. Well, that means we need to find the mean. Well, if you add up all of these numbers and divide by 14, the mean in this case is 5. So in our case, the mean is equal to 5. We've already learned how to do that. So you can go through and add up all these numbers and their mean is 5. So I'll just write that here, x bar is equal to 5. Now we're going to subtract the mean, so xi minus x bar. Later I'll skip this intermediate step. Then we need to find each one squared. So 5 minus 5 is 0. And 0 squared is 0. And 5 minus 5 is 0, and 0 squared is 0. And 3 minus 5 is negative 2. And negative 2 times negative 2 is positive 4. And 7 minus 5 is 2, and 2 squared is 4. And 5 minus 5 is 0, and squared it's 0. And 7 minus 5 is 2, and squared it's 4. 3 minus 5 is negative 2, squared it's 4. And 1 minus 5 is negative 4, squared that's 16. 9 minus 5 is positive 4, squared it's 16. 5 minus 5 is 0, 0. 3 minus 5 is negative 2, squared it's 4. 7 minus 5 is 2, squared it's 4. 5 minus 5 is 0, squared is 0, and that's it. So now we need to add those numbers together. 0 plus 0 plus 4 plus 4 plus 0 plus 4 plus 4 plus 16. It all adds up to 56. Divided by 14, and that's equal to 4. So the variance is 4. If you were playing the game with these numbers over here, we can play the game with those numbers. Not these numbers, we'll use these later on this side of the card. Later you'll be able to use this number to predict what's on the other side of the card. But right now you're just guessing randomly because you don't know anything yet. You're guessing one of these numbers. What's the best thing you can do? Guess 5. Why? Because it's the mean. And what's the best thing to do if you're playing the variance game? Guess the mean. In this case, that's 5. So what do you guess? Good. All right, 5 minus 3, then $4. How much will it cost you on average if you play this game? A whole lot.
Nothing.
Why nothing? Just cost her $4. You want to make a guess? Isn't it going to come out sometimes you have to pay $4?
I guess.
And if you guess
I guess they're
five,
never gonna
sometimes
pay.
9 is
they're-
gonna happen.
You're never gonna pay them anything.
How much is
What
it?
a
Yeah, how much is it gonna
terrible
cost?
deal.
I mean, there's a lot of deals that are terrible deals in life. Think about it. You got these prisoners. You know, if you keep them in jail, what happens? You have to pay to keep them in there. It costs more to keep somebody in jail than to put somebody in Harvard. That's why somebody suggests, let's take these people out of jail and send them to Harvard. At least we can get them out of the state, you know, we can pay their tuition and send them to Harvard. Because it costs more you gotta have guards watch them, you gotta feed them, you gotta house them, and you gotta have bars and strong building, you know, to keep them, you gotta have somebody looking at them all the time, make sure they're not using their spoon to dig their way through, dig their way out, you know? Or that they're killing other prisoners or guards. It's expensive to keep somebody, and then if you let them go, what happens? They go out and they commit more crimes and cost you money. You have to go back through the court system. You have to have policemen cost you money to chase them and arrest them. There's a lot of things that cost money. You know, you don't do anything about ISIS. What happens? They'll go around killing people, and if you go to war against them, it costs you a lot of money. You got to hire soldiers. You got to buy weapons. You got to ship people across the seas. If people are going to die. I mean, there's a lot of things where it costs you money no matter what. When you make a mistake and let somebody out that should be kept in jail, they're going to cost a lot of money, cause you problems. And if you keep somebody in the jail, you got to pay money to keep them in there, and they could be out there, maybe if they would go straight, you've made a mistake by keeping them in jail when they could be out there supporting their family, earning, you know, going to work, earning a living. So there's a lot of things like that. The variance just tells you how bad is the mean at describing these numbers. How far off it, and only if the variance is only 0 if all the numbers are equal to the mean. So if they were all 5, then your variance would be 0. But otherwise, the variance tells you the average cost of playing this game is $4 if it's in 4. So the variance is the average cost of playing the variance game. All right. Now the square root of the average squared mistake, that's called the standard mistake or the standard deviation. It's not exactly the same as the average absolute deviation, but it's kind of like that. So it's called the standard deviation. It's equal to the square root of the variance. And in this case, the variance was 4, so the standard deviation is 2. So we can say that the standard deviation in this case is the square root. It's always the square root of the variance. So if the variance was 100, the standard deviation would be 10. And if the standard deviation was 1, the variance would be 1. If the standard deviation was 5, the variance would be 25. If the variance was 36, the standard deviation would be 6. So you either square 1 or take the square root to go back and forth between the variance and standard deviation. So you should memorize these 2 equations. All right. Any questions about how to calculate a variance and a standard deviation? How to find a frequency distribution, mean, median, mode, midpoint, the claims to fame. And these different numbers create different impressions. Let me ask you this. What kind of distributions are symmetric or asymmetric or positively skewed? Some distributions are symmetric. We're going to learn more about this particular symmetric bell-shaped curve called the normal distribution. In the normal distribution, it's a bell-shaped curve whose mean is equal to the median, mode, midpoint. Then there are some distributions that are positively skewed. And you already saw one by reading chapter 2 of Callett. What's the one, the example he gives from Huff's book, How to Lie with Statistics? In Huff's book, he takes a figure from Huff and he reproduced it in chapter 2. What's a famous positively skewed distribution? Distribution of income. If I count everybody's income in the United States, and I mean everybody's, so let's literally not just look at people that are employed, but the whole country. What value of income is more frequent than any other value? What's the mode income in the United States? What do more people earn than any other value? I think I heard some people whispering. Don't know if they were whispering the right answer. Anybody want to speak up? What's the most frequent, what value of income do more people have, counting everybody, than any other value of income? 0, right? Newborn babies earn 0. You know, people that are sick in the hospital that aren't earning anything, they're 0. So more people earn 0 in this country than any other value. Positively skewed distributions are distributions where a lot of people are close to 0, a lot of cases are close to 0, but there isn't really much of a bound at the upper end. And what's the highest income in this country? Bill Gates, maybe he's up there. Yeah, I think he might be the top income earner, earned $1 billion, mainly because his Microsoft stock went up quite a bit. Maybe he earned more than $1 billion this year, simply because of the value of the stock. Which would you rather have, the mean income in the United States or the median income? The median income, half the people earn less and half the people earn more. Mean income, you add up all the incomes, divide by n. So which would you rather have, mean or median income in the U.S.?
The mean.
How many say the mean? How many say the median? Well, if half the people are earning 0, would you like to earn like just above that? That'd be the median, right? The mean, no, you average in, remember? The mean, you add up all the numbers. If you add this, if this number becomes really big, it makes this number big, makes the mean big. So you'd rather have the mean. The mean is greater than the median, is greater than the median in a positively skewed distribution. Hardly anybody earns the mean income in the United States. Most people are below average. Almost everybody is below average in the United States. And of course, it's becoming more extreme in the last 12 years. Ever since we got those big tax cuts that went to the wealthy, the income distribution in the United States has become more skewed. The difference between the wealthy and the rest of the country has become much more extreme. Right now, 6 people have as much wealth as 43% of the population at the bottom. 6 people, the 6 Walmart heirs to the Walmart fortune, have as much wealth in this country as 43% of the whole country. Add up everything they own, adds up to those 6 people. So would you like to have the median income or the mean income? The mean. Would you rather have the midpoint income? Let's think about it. Somebody shook their head no. Would you rather have the midpoint? What's the midpoint income? The smallest plus the largest divided by 2. What's the smallest? 0. What's the largest? Billion. Think you could make it on $500 million a year? I mean, I know you're just college students. You don't know the value of money yet, according to your parents, but $1 billion is a lot of money, believe me. All right. So yes, you could do quite well. You'd most rather have the midpoint of the incomes. What kind of things are negatively skewed? So things that are bounded by 0 at one end, and there's no real bound at the upper end, like number of sex partners. Khaled gave you the example of the number of desired sex partners. So he gives the example in the chapter 2 of how many sex partners would you like to have, but he doesn't give you the whole distribution. Then he points out that the average for males is like 63. Or how many sex partners would you like to have in the next 5 years or something in the men? But one person could have, simply by writing down 1 million or something, could have really pulled that number way out there, right? So in a positively skewed distribution, what kind of things where a lot of people are close to 0? Number of cavities, number of articles published by professors at Cal State Fullerton or any other place. Number of diseases that people have, number of STDs. Any of these things are going to be positively skewed. You have a lot of people close to 0 and no real upper bound at the upper end. Income. What kind of things are negatively skewed? Things where most of the scores are at the top, an easy test, like a true-false multiple choice test, where the students are doing well. It's always somebody that does worse than chance on a multiple choice test. 50-50 is guessing. Most people are going to be above average. So a negatively skewed distribution, most people are above average. The mean is below the median. All right. Let's answer 4 medical treatments. Hopefully you got drugs. And that's the main way that